Well, students, in previous period, we have seen the preparation methods of the phenols. Now, after these preparation methods, come toward that the next article of the phenol, and this article is related to the about that the physical properties. So, our next point is that the physical properties of the phenols. Physical properties of phenols. Now, the first physical property is about that the state of the phenol here. Now, the phenol is colorless, crystalline solid. Colorless, crystalline solid. Means what is the meaning of this property here? Means when phenol is in a pure state condition, that time it has no any color and it is a solid in state and it is a in crystalline solid. You know that there are two types of the solids. One is the crystalline and another is that is the amorphous. But when it is a pure in state, that time it is a colorless crystalline solid. Okay. Then second point about that the odor of the phenol. Phenol has characteristic odor. Phenol has characteristic odor, and this odor is known as carbonic odor. Is known as carbonic odor, or this odor is also known as phenolic odor. Phenolic odor. Okay, so they have the particular that the odor here, and that odor is known as the phenolic or the carbonic odor. Now, then after that, next point of the phenol is phenol on exposure. Phenol on exposure to air or light to form pink coloration, due to oxidation and forms mixture of phenols. Okay, so this is the third property. Means in this third property, what I have said here that phenols on exposure to air or light, means when phenol when come in contact with the air or the light, then the colorless phenol converts into the pink colored compound. Okay, and actually why this phenol here that converts colorless compound into the pink color compound? Due to its oxidation here. Means here in this state here that the phenol's oxidation takes place here. Okay, and due to this oxidation here that phenol gets converts into that the mixture of the phenols here. Now in this that the property, there should be one MCQ here that phenols on oxidation to form that dash. Then the answer is that the quinones. Of course here that the phenoquinones or the benzoquinones are formed here of the quinones here. Okay, so this should be the very important point here. Okay, now after this that the property, then the next property of the phenol about that the solubility. Phenols are sparingly or less soluble. Phenols are less soluble or sparingly soluble in water. While it is more soluble is more soluble in organic solvents, more soluble in organic solvents, and also in NaOH, means sodium hydroxide. Of course, that this property is a very simple one here, that phenols are less soluble in the water, whereas it is highly soluble in the organic solvents and in NaOH also. Now, the next physical property of the phenol, about that the melting point and the boiling point. Phenol has 315 melting point and boiling point is 455 Kelvin. Okay, so here melting point is 315 Kelvin here, whereas the boiling point is the 455 Kelvin here. Then the next point of the phenol is acidic in nature. Phenol is acidic in nature. Okay, so these are the some physical properties of the phenols here. Okay, actually on this type of physical properties, the question may ask, particularly in the board exam, that write any that the 4 physical properties of that is the phenols here. Okay, the point is very simple one or very easier one. Now, after this that the physical properties, then come for time the next important article of the phenol, and it is the chemical reactions of the phenols here. Chemical reactions of phenols. Chemical reactions of phenols. Well, students, now you know very well that the OH group is attached to the aromatic ring, and that is known as phenols here. Or already we have discussed or seen that in the definition, in phenols that OH group is directly attached to the aromatic ring here. Okay. Now, actually this OH group in phenol activates the ortho and the para positions in the phenol. Okay. Now, once again, I would like to repeat this point here. Due to this OH group in the phenol activates the ortho and the para positions in the phenol. Now, this point is why important, because here that in all the chemical reactions of the phenol, we are going to show the substitution of that groups in which positions in as either that the ortho or the para positions. Now, after this point, that the next here that the point or the next question arises here, that the why in the phenol that on the ortho and the para positions the substitution may take place here. Now, the answer is like this here, that on the here that these ortho and para positions in the phenols are the electron rich positions here. And why these are the electron rich positions? Due to the resonance phenomenon. Answer is that due to the resonance phenomenon. Means in the phenol here that here continuous delocalization of the electron takes place here, and therefore here that the substitution may take place at the here ortho and the para positions here. And the negative charge also, if we see here that the resonating structure of that is the phenols here. Okay, then the negative charge here is at the ortho or the para positions here. Now, I would like to draw here that the here resonating structures of the phenols here. Now, this should be the our here phenol here. Okay, this should be the here phenol here. Now then here the electrons here may here transfer at the ortho and the para position. Okay, this should be the first structure here. Then after that, the next one structure is like this here. Then next resonating structure is like this here. Then after that, the next structure is like this here. Okay, and here the negative charge is here. Okay, now this should be the ortho position here. This should be the here para position here, and again this should be the here ortho position here. So this is the structure first. This should be the second, third, here fourth one, and this one is the fifth structure. Now here if we observe all these five structures here, and all these are the resonating structures of phenols here. Resonating structures of phenols. Okay, if we observe here that all these resonating structures, then the negative charge is at ortho or the para positions, and these ortho and the para positions are the electron rich positions here, and due to this resonance here, therefore the chemical reactions of the phenols, or in these chemical reactions the substitution may take place at which position? At the ortho or in the para positions. Okay, so this is the resonating structures of that is the phenols. Now after this resonating structures of the phenols, now come toward that the actual chemical reactions of the phenols, and in these chemical reactions, that the first chemical reaction is that about acidity of the phenols here. Acidity of phenols here. Now the word is indicate that, or in physical property we have seen that phenols are the acidic in nature. Remember that students, that in this lesson here, that alcohols we have discussed. Alcohols are also that the acidic in nature, and their reaction is like this here. ROH, alcohol, when it dissociates to give that the alkoxide ions here, and H plus ions are liberated, or the evolution of proton takes place here. Now this evolution of the hydrogen ion indicate that alcohols are the acidic in nature. Okay, that point we have discussed here. And among this point I have told you that in alcohols, when alcohols react with the alkali metals like the sodium metal, potassium metals, or the aluminum metals, then it gives that the corresponding alkoxides, which evolution of the hydrogen gas, and this evolution of the hydrogen gas indicate that alcohols are the acidic in nature. Okay, so you know that very well. Now like that here, the phenols are also acidic in nature. Means when phenol reacts with these alkali metals, means which alkali metals, like that the sodium metal or the potassium metal or the here aluminum metals or strong base like that the NaOH also. Okay, then it dissociates into the phenoxide ions. Means here phenoxide ions are formed with evolution of the H plus ions here. Now, these are the phenoxide ions here. Phenoxide ions. Okay, so here due to this here evolution of the hydrogen gas here, again that here it indicates that phenols are the acidic in nature here. Okay, so actually this is the difference between that the here the acidity of that is the alcohols and that is the phenols. Actually, of course, that the both are acidic in nature here. Okay, that again that I would like to tell you that the one point here that the alcohols are acidic and phenols are also acidic in nature, but the what is the difference between these two here, that the phenols are millions times more acidic than the alcohols. Yes, again I would like to repeat here, phenols are millions times more acidic than the alcohols. Okay, but phenols are less acidic than the carboxylic acid. Means carboxylic acids are the stronger acids. Okay, and the phenols are weaker acid than the carboxylic acids here. Okay, now here after this description, that come to that the next point, phenol is a bifunctional compound. Now the question arises that why the phenol is that is the bifunctional compound? Because that the phenol contains that the OH group and as well as that is the aromatic ring here. Now here in the phenol, the reaction takes place due to this OH group as well as due to this aromatic ring here. Therefore, the phenols are the here bifunctional compounds here. And one more point about that the phenol and about that this phenoxide ion, I would like to tell here that the phenoxide ions here more stable than the phenols here due to the resonance phenomenon here. And as the phenol is a bifunctional compound, and here the reaction takes place due to this OH groups and the benzene ring here, that the phenol undergoes the electrophilic aromatic substitution reactions here. Now, why the reaction takes place here that the electrophilic aromatic substitution? Now, because here that the here from this phenol here that the hydrogen atom gets replaced here. Therefore, the reactions are the electrophilic here. And why the reactions are the aromatic? Because that the phenol contains that the OH group here, OH group here. Therefore, in phenols that the reactions are of the electrophilic aromatic substitution reactions. Okay. So our next reaction of the phenol is the electrophilic aromatic substitution. Okay.